Question 1. The probability that a biased dice will land on a 6 is 0.3. The dice is going to be rolled 200 times. Work out an estimate for the number of times the dice will land on 6. Well, if you do one roll, you get a probability of 0.3 to land on a 6. So as a dice, and if you land on a 6, you get 0.3 probability. So if you do 200 times, so if I multiply 1 by 200, I get 200. I have to times 0.3 by 200, so I get 0.3 times 200, and that gives 60. So the answer here should be 60. Question 2. The probability that a sunflower seed will germinate is 0.9. Alan is going to plant 50 sunflower seeds. Work out an estimate for the number of seeds that will germinate. So again, I have one sunflower seed will germinate with a probability of 0.9. So if I'm going to then do it 50 times, that means I'm going to multiply 1 by 50. I get 50, so that means times 50. So I have to times 0.9 by 50. So what? 5 times 9 is 45. So that'll be 45. So that is going to be 45 because 0.9 and 50, 10 and 10 to the power minus 1 will give you 1. So that'll be 5 times 9. So 45 equals 0.9 times 50. Question 3. The probability that Frank scores a penalty is 0.86. Frank is going to take 50 penalties. Work out an estimate for the number of times Frank will score. So again, for one penalty, I've got a probability of 0.86. So if I again multiply that by 50, sometimes in by 50, I need to times that by 50. So 0.86 times 50. I could quickly do that by, I know it's going to be 43 because 50 is like 0.5, which is a half. So half means divided by 2. So I should get 43. But in the case of just trying it with a calculator, you turn that on, 0.86 times 50 should be 43. Yep, 43. Well, how do I know it's 43? Well, 8 divided by 2 is 4. 6 divided by 2 is 3. 0.5, if I move the point here, and I move that there, and I move that there, and I move that there, what I'm saying is I've got 0.86 and I've got 50. So if I move the point from 0.8 to there, and I have to move the point here to there, so they counteract each other. And if I move the point to there, I'm going to get 86. And if I move that point also to there, I get 0.5. 0.5 is a half. A half means, so if you have times in them, so that will be 86 times a half, which means 86 divided by 2. Again, that will be 43. So the answer is 43. Question 4. The probability that Matt scores a penalty of is 0.96. Matt is going to take 25 penalty. work out an estimate for the number of times Matt will score. Now we know what's going on. Again, 1 penalty has a probability of 0.96. I'm taking 25, so I need to multiply that by 25. So I will get 25. So that's times 25. And I need to times that by 25 as well, times 25. Well, now you know the way to work this out. If you're not using a calculator, you need basically to do 0.96, and then I've got 25. Well, so if I move the point from there to there, I have to move the point from there to there. And if I move the point from there to there, I move the point from there to there. So the same thing. So that means I've got 96 times in by 0.25. Well, 0.25 means a quarter. So that would be 96, right? Times 1/4. And that means 96/4. How many 4 goes in 9? That's 2. So that would be 2. I've got 1 left. Put 1 over there. How many 4 goes in 16? That's 4. So the answer should be 24. So we get 0.96 times 25, and that is 24. So that's how you do that multiplication quickly. Now, question 5. Say in a bag, there are only red counters, blue counters, and white counters. A counter is taken at random from the bag. The table shows the probability of the counter being red and blue. So you got a table here, you got a color, red, blue, and white. Probability is 0.5, 0.3. Complete the table to show the probability that the counter will, and show the probability that the counter will be white. Well, in this scenario, you know that the total probability in any event is going to be 1. So we could write that down. Total probability of an event is equal to 1. I've got the probability here to be 0.5 and 0.3. And if you add 0.5 and 0.3, you get 0.8. So we could say 0.5 plus 0.3 equals 0.8. Now to find the probability of white, we have to do 1 minus 0.8, and that gives 0.2. So the probability for white will be 0.2. Again, for question 6, in a box, there are only black pens, blue pens, and green pens. A pen is taken at random from the box. The table shows the probability of the pen being black and blue. So you got 0.64 and 0.24 for blue and black. Complete the table to show the probability that the pen will be green. Again, total probability is 1, right? So probability of the total system is going to be 1. Now, probability of black is 0.64 and blue. So if we add them together, you're going to get 0.64 for black plus 0.24 for blue, and that gives 0. So 6 plus 2 is 8, so 0.88. Now to find the probability of green, we have to do 1 minus 0.88, and that will be 0.12. So the probability for the green will be 0.12. Again, for question 7, we got the probabilities now for the a bias spinner can land on red, blue, yellow, and green. The table shows the probability that the spinner will land on red, blue, and yellow. We got the colors in probability. For red is 0.25, blue is 0.34, and yellow is 0.22. For green, again, the total probability. So the probability for the total system, I say, is 1. And if we add the probability of red, blue, and yellow together, we get 0.25 plus 0.34 plus 0.22, and that gives 0.81, because 5 plus, that's 9, 10, 11, 1, we carry 1, 2, 3, that's 5, 7, and 1, 8. Right, so probability of green will be 1 minus 0.81, and that will be 0.19. So the probability for green here will be 0.19. Question 8. In a bag, there are only red counters, blue counters, and white counters. The number of red counter in ratio, that's colon means ratio. So number of red counter colon, number of blue counters colon, number of white counters is equal to 5 colon 4 colon 3. A counter is taken at random from the bag. We got a table for red, blue, and white. Complete the table to show the probability of the counter being red, blue, and white. Right, so the total in a ratio, so what you need to do in this case is to add up the total of the ratio here. So that would be 5 plus 4, that would be 9. 9 plus 3 is 12. So that means you got the total here of the ratio, which is 5 plus 4 plus 3, and that equals 12. So now the probability will be 5 over 12 for red, so that will be 5 over 12, and for blue will be 4 over 12, so that will be 4 over 12, and for white will be 3 over 12, so that will be 3 over 12. Because these are the ratio of the red, blue, and white in the total of 12. Question 9. Okay, in a bag, there are only black counters, white counters, and red counters. The counter is taken at random from the bag. The table shows the probability of taking a black counter and a white counter. Color and probability table. You go to black is 3 over 10. White is basically 3 over 5. And what would be the red? Well, so just like we've done in question 8, what we need to do here is make the denominator the same for these two. So we've got 3 over 10 for black plus 3 over 6 over 5. 3 over 5. Well, we need to make 3 over 5 or the 5 same denominator as the 10. So I need to times this by 2. I have to times that by 2. So I will be getting 3 over 10 plus 6 over 10. Which means if I add them together, I should be getting 9 over 10. Because because they have the same denominator, you add the numerator, and so you're going to get 9 over 10. Now, you know the total probability is 1. So probability of the total system is 1. In that case, I have to do 1 minus 9 over 10. If I'm doing 1 minus 9 over 10, just to do that properly, it's actually 1 over 1 minus 9 over 10, which means I need to make them the same denominator, so that will be 10 over 10 minus 9 over 10. Well, 10 minus 9 is 1, so that will give me 1 over 10. So the probability for red here will be 1 over 10. Okay, for question 10, a biased spinner can land on red, blue, yellow, and green. The table shows the probability that the spinner will land on red and yellow, so that's red and yellow. The probability of landing on blue is the same as the probability of landing on green, so blue and green are the same. Complete the table to show the probability of spinner landing on both blue and green. Well, so again, we know what the total probability would be, 1. The total probability will be 1. So the best thing to do is to add these two together and take away from 1. And then whatever we get divided by 2 to get the value for B, blue, and green. Okay, so let's add these red and yellow together, which is 0.18 plus 0.26, and that should give 0.44. All I need to do now is do 1 minus 0.44, and that should give 0.56. Now I need to divide 0.56 by 2. So if I do that here, 0.56 divided by 2, and that will give, well, that will be 0.2, because 2 goes in 5, 2, and then you got 1 left. 2 goes in 16 as 8, 0.28. What that meant is now that this one is going to be 0.28 and 0.28. Why did I do that? Because it says here that the probability, it says here that the probability for blue is the same as the probability from green. So that those two are meant to be the same according to the question here. So you have to check the question carefully before you launch your attack. So that's the answer there. Question 11. A biased spinner can land on red, blue, yellow, and green. The table shows the probability that the spinner will land on red, blue, and yellow. So that's why we got the value for this. We need to find the value for green. Complete the table. So we need to complete that. Well, so we know that the total probability is 1, right? Probability of the total systems, I just put T there, equals 1. And therefore, what I need to do now is to say, well, what I can say is to add all this together and take it away from 1. So 0.3 plus 0.25 plus 0.15 will give, well, that's 0.4, and 0.3, that's 0.7. Now to do 1 minus 0.7 will be equal to 0.3. So the probability for the green will be 0.3. So we get 0.3 there. Kelly is going to spin the spinner 60 times. Work out an estimate for the number of times the spinner will land on red. Well, the probability to land on red is 0.3. So when you get one probability of when one spin on red gives 0.3, and if you do it 60 times, you're going to multiply that by 60. So times 60, you get 60. You have to times that 2 by 60. All right. So you're going to get 0.3 times 60. Well, because you're doing 0.3 and you're doing times 60, the answer is going to be 6 times 3. And that would be 18. How do I know it's 6 times 3? Well, so you can see you got your 0.3 and you got times 60. If I move the point from there, I'm just going to move it there. I have to move the point from there back here. Okay, which means I'm going to get 3 times 6, and that's 18. Because if you move the point one way, you have to move the other point the other way. So we've got question 12. In a bag, there are only red counter, blue counters, red counters, blue counters, and white counters. A counter is taken at random from the bag. The table shows the probability of getting a red counter. That one, 0.2. The probability of getting the blue counter is the same as the probability of getting the white counter. Complete the table. We know that the total probability is going to be, let me just put it this way, probability total, right, is going to be 1. And because it's going to be 1, I need to then take away that from the red. So the 1 minus 0.2, and that will give me 0.8. And I need to divide that by 2 to get 4, because the probability of the white and blue is the same. So I have to do 0.8 divided by 2, that will be 0.4. Each one in this table is going to be, apart from red, is going to be 0.4. And that adds up to 1. Now, there are 18 red counter in the bag. There are 18 red counter in the bag. Work out the total number of counter in the bag. Okay, so we know that there are 18 red counter in the bag. So what we have to do now, 18 is 0.2 is the probability of that. And if you multiply it by the number of throws, or the number that you took, the number of times you've taken it out, that'll be x, will be 18. When we need to find x, so x will be equal to 18 divided by 0.2. Well, at this point in time, I could just do, we'll move the point up there, and then I have to move the point up. If I move the point there, I have to move the point there. So I'm going to get 18, 180 over 2. Because I move the point to the right, I move that point to the right as well, because I'm dividing this time. I'm not multiplying. And that gives us 180 divided by 2 is 90. So that would be, x is going to be 90. Or you could say that I have times the denominator by 10, I need to times the numerator by 10. So if I times the denominator by 10, I'll get 2. If I times the numerator by 10, I get 180. Now it's easy to divide. Question 13. A biased spinner can land on 1, 2, 3, or 4. The table shows the probability that the spinner will land on 2 and 4. This is 2 and 4. The probability that the spinner will land on 1 is twice the probability that the spinner will land on 3. So what we're saying is, if the probability of 3 is x, the probability of 1 will be 2x. So that means we're going to get 3x. So now what we need to do is complete the table. To complete the table, I need to add these two together, take it away from 1, as we know that the total probability is going to be 1. So what we can do now is to say 0.32 plus 0.17 is going to be 0.49. So 1 take away 0.49 will then give me the probability of 0.51. Now I know that I've got, for these three here, for these two, I've got 0.51. So I have to do, well, this is 2x plus x is 3x. So now I need to divide, and I know that, let's put it this way, the 3x will both, well, equal to, they'll both equal to 0.51. So if I divide both sides by 3, I get 0.51 divided by 3. 0.51, how many 3 goes in 5 is going to give me 0.2. So 1 says 1. How many 3 goes in 5? 1. Then you got 2 left. How many 3 goes in 21? 7. How many 3 goes in 21 will be 7. So x is 0.17. Because I said, well, how many 3 goes in 0? No, so 0 point. How many 3 goes in 5? 1. What's left? 2, because 5 minus 3 is 2. And put a 2 here, that's 21. How many 3 goes in 21? That'll be 7. So if this one is 0.17, that would be 0.17 times 2, which is 0.34. So if that's the table completed, Johnny is going to spin the spinner 200 times. Work out an estimate for the number of times the spinner will land on 2 here. So you know that's for 1. If that's for 1, for 200 times, you go to do, obviously, 1 will give you 0.32. And if you multiply that by 200, so you're doing it 200 times, that'll be 200. You want to times that by 200. So that'll be 0.32 times 200. Well, again, you might be thinking, how do I multiply that without a calculator? Well, in that case, you could basically do the same thing by doing 0.32 times 200. Move the point 1, 2. Right? That's 32. And you have to move that point 1, 2. That'll be 2. So you move it backwards. If you move it to the right, you have to move that to the left. So that would be 32 times 2, and that gives you 64. So the answer is 64. Question 14. The table shows the probability that a biased dice will land on 1, on 2, on 3, on 4, and on 6. The probability number and the probability is shown in the table. And we need to complete the table. The dice is rolled 200 times. Work out an estimate for the number of times the dice will land on 2 and 4. Well, we haven't got the 4 value for 4, so we need to complete that. In order to complete that, we need to add up all these and then take it away from 1, because the total probability will be 1. So the total probability has to be 1, which means that you're going to do 0.14 plus 0.2 plus 0.08 plus 0.13 plus 0.21 will be equal to 0.76. If that's 0.76, what do I do now? So you have to say 1 minus 0.76, and that should be equal to 0.76. 0.24. And so what we now need to do now is, we know that 0.24 will go here in the table here, so that's 0.24. And so the next point to do is to work out the probability for that will land on 2 or on 4. Now, to land on 2 or 4, we need to basically say for 2 or 4 probability. So we're going to get or is a plus. That's what or means. Whenever you see that word or, it means plus. So it's going to be 2 plus 4, in this case 0.2, and for 4 is 0.24, excuse me, 0.24. So the probability for, because the or means plus, and so that means you add their probabilities. 0.2 for 2 plus, that's the or, 0.24 for 4. So the or implies, or means plus. That's why we're plusing it. And that gives us 0.44. So that's the probability for 2 or 4, 0.44. And if you're doing it 200 times, you know, we have to then multiply it by the 200 times, because for 1 time is 0.44. So 1 is probability of 0.44. And if you multiply that by 200, so that's times 200, you have to times that by 200 as well. And that would be, well, 0.44 times 200. So you can see, we know what to do now. Just move the point 1, 2, that'll be 44. And you have to move this one from that point to the left. When you move that to the right, 1, 2. So that's 44 times 2, which is 88. So that equals 88. Just to show the point movement, just in case any confusion, we'll do it here. 0.44 times 200. The movement of point, just move that point 1, 2. That will become 44. And you move that one from there because there's a point there. 1, 2. That will become times 2. Because you move the point same times in the opposite direction, that will give you 88. And that's how you do that. Question 15. In a box, there are only red pens, blue pens, black pens, and green pens. A pen is taken at random from the box. The table shows the probability that the pen will be red or will be green. The probability that the pen will be black is 3 times the probability that the pen will be blue. So if if that was X for blue, the black will be 3 times 3X. That's why we call it. So let X be the probability for blue, and the probability for black will be 3X because it's 3 times. So the clue to the questions is in the text. And therefore, there are 28 green pens in the box. Work out the number of black pens in the box. Alright, so this is quite intriguing. The first thing is to complete the table, because we know the total probability is going to be 1. So what we can do now is to work out this one by adding these two together and take it away from 1. And what's left is equal to the 4x. So I will be saying 0.42 plus 0.14 will be equal to 0.44. 0.56. So the 1 minus 0.56, and that will give us 0.44. So now we got the 3x plus x is 4x. So therefore 4x is equal to 0.44 because those two equals to 0.44. And so now divide both sides by 4. X will be equal to 0.44 divided by 4. How many 4 goes in 4? 1. How many 4 goes in 4? 1. So that gives 0.11. So x, if this one is 0.11, this is going to be 0.33 because you multiply it by x by 3. So that's the table completed. Now the question says there are 28 green pens in the box. Work out the number of black pens in the box. Well, so for black pen, I've got 0.33. Right. So what we now have is we're going to say, if we have 28 green pen in the box, we will know the number of green pen in the box. So we have to say, well, 0.14 for the green pen times, let's say, the total in the box. If the total in the box is y, all right. So the total in the box is y because we don't know what it is. So the proportion of the green pen is 0.14 times y. It's going to be right. It's going to be 28 because it's a ratio, right? That's a ratio of green pen times the total in the box. All right, and that equals to 28. Now we know that. We can find the total in the box. So y will be equal to 28 divided by 0.14. We know how to do that one because we can move the point along. So if I move the point, if I times that by 100, I need to times that by 100. Let's times the denominator by 100. I'm going to get 14. 1, 2. That's timesing it by 100. And to times that by 100, I'm going to add 2 zeros. And if I'm dividing it by 14, how many 14 goes in 28? 2. So that would be 200. Good. So the total in the box is 200. Now to find the number of black pen in the box, it's going to be multiplied by the ratio. So for the number of black pen in the box, so this is for black pen, and that one here is for green pen. Right, that's for green pens, and this one is for black pens. So for black pen in the box, I should be saying there will be 0.33, the ratio of the black, times the total. You have to multiply by the total because it's a fraction of it. And that should give us, well, if I move that point 1, 2 to the right, I have to move the point from here 1, 2 to the left, which means 2 times 33, which is 66. All right, so that's 66. How did I do that again? Well, remember I have got 0.33 times 200. There's a point here. So what you need to do is move the point 1, 2, right? Or basically, I'm dividing this by 100 and I'm timesing that by 100. Divided by 100 times it by 100. That's what we're doing. So if I do that, I shall get, if I times that by 100, I'll get 33. I need to divide that by 100, I'll get 2. So 33 times 2 is 66. So the answer we're looking for is 66. Just to move that up a bit to see that's the answer we're looking for. 66. 16. In a bag, there are only red counters, blue counters, green counters, and yellow counters. A counter is taken at random from the bag. The table shows the probability that the counter will be green or will be yellow. We got the color and the probabilities, red, blue, green, and yellow are given. We know that the total probability will be 1. Because if we add everything together, we get 1. So the probability that the counter will be red is twice the probability that the counter will be blue. So again, another clue to what we need to do is there. So if this is X for the blue, counter probability, that will be 2X. Right, so what we now need to do is to complete the table first of all, and then we can answer these questions here. There are 21 green counters in the bag. Work out the number of red counters in the bag. Okay, so what we now have is we need to add these two together and take it away from 1, and then what we get will be equal to the sum of these two. So I'm going to start with 0.35 plus 0.2 will be equal to 0.55. Now I need to do 1 minus 0.55, and that should give 0.45. So that means the sum of these two equals 0.45, which implies that the 2x plus x, which is 3x must equal to 0.45. Divide both sides by 3, I shall get x to be equal to 0.45 divided by 3. How many 3 goes in 1? So I'm getting 0. How many 3 goes in 4? 1. What's left? 1. Put 1 there. How many 3 goes in 15? That would be 5. So that would be 0.15. Now we know what that's 0.15. So x, the blue, is going to be 0.15. And this is twice that. So now 0.15 times 2 will be 0.30. So now we know what the red and blue are. Then the question says there are 21 green counter in the bag. Well, if that's the case, well, so for green counter, just look for green counter, I have the ratio of green, which is 0.35 times the total in a counter. So I'm going to call that T for the total in the bag. Yeah, that's total. So that the ratio of that should be equal to the number of green, which is 21. So I need to divide both sides by 0.35. So T for the total in a bag would be 21 divided by 0.35. Well, if I times this by 100, I need to times that by 100. So I'll get 2100 over 35. I just times the denominator by 100, and I times the numerator by 100. So how many 35s will go in 210? 35 into 10 is 6. So that would be 60. So the total in the bag is 60. For now, to work out the number of red counter in the bag, I have to then do for red in the back. I have to then do the proportion of red, the ratio of red is 0.3 times 60. Again, well, so it's just going to be, if I times that by 10, I have to divide it by 10, right? Times this by 10 divided by 10 to balance it out, that'll be 3 times 6. I'm expecting 18. So for that one, and I'm expecting 18, let's just move this up a little bit. So that's 18. So the answer we're looking for is 18. So that'll be the answer we're looking for there, 18.